Welcome back to the real number system. In this video, we'll continue our discussion of section 3.4, talking about multiplication of whole numbers. Let's get started. We begin with our algorithms for multiplication. Our first algorithm is the base 10 blocks, or the concrete model for multiplication. This model uses our set theory. So with the base 10 blocks, remember we're using our units for our ones, our longs for our tens, and our flats for our hundreds. In our first example, we're multiplying 4 times 12. Well, we can write 12 as 1 long and 2 units. In our previous video, we looked at multiplication as repeated addition. The first number tells me how many times to add the second number. So I'm going to add 12, or 1 long and 2 units, 4 different times. This gives me 4 longs and 2 units plus 2 more plus 2 more plus 2 more is a total of 8 units. Our longs represent our tens, so that's 40, and our units represent our ones, so we have 48 for our answer. Here, we're multiplying 3 times 243. 243 we write as 2 flats, 4 longs, and 3 units. Since we're multiplying by 3, we're going to add this 3 different times. 2 flats plus 2 more plus 2 more is 6 flats. 4 longs plus 4 longs plus 4 longs is 12 longs. And 3 units plus 3 units plus 3 units is 9 units. Remember, 10 longs make a flat. So I need to exchange 10 longs for a flat. That gives me 7 flats, and I have 2 longs left. Bring down your 9 units. The flats represent our hundreds place, the long represents the tens place, and the units represents the ones place. So our answer is 729. Our next algorithm is the partial products algorithm. This model emphasizes our place value. For our first example, we have 3 times 243. So I start with the ones place. 3 times 3 is 9. The 4 represents 40. So I have 3 times 40, which is 120. Then I move to the hundreds place. The 2 represents 2 hundreds. So 3 times 200 is 600. Then add, and we get 729. In part B, we have 23 times 14. Again, I start with the ones place, and I'm going to multiply by the ones place in our second number. So 4 times 3 is 12. The 2 represents 20, so I have 4 times 20, which is 80. Now I move to the tens digit in the second number. So the 1 represents 10, so 10 times 3 is 30. Then I have 10 times 20 is 200. Add your ones column, that gives us 2. When I add the tens, I get 12 tens, so I have to regroup. 10 tens make an extra 100. And that gives me 3 hundreds. Our next algorithm is the standard algorithm that you are probably familiar with. This is probably the way that you learned to multiply. You may have learned the term carrying, but now we use the terms regrouping or trading so that it matches what we do with the manipulatives. First, we have 12 times 4. So 2 times 4 is 8, and 1 times 4 is 4. And our answer is 48. Then we have 3 times 243. 3 times 3 is 9. 4 times 3 is 12. That's 12 tens. 10 tens we regroup for an extra 100. Then 2 times 3 is 6, plus 1 more 100 makes 700s. I want to add an extra example that's not in your notes. So let's multiply 23 times 14. 3 times 4 is 12 ones. 10 ones make a 10, and so I have to regroup and add an extra 10. 2 times 4 is 8 tens, plus 1 more is 9. Then I move to the 1. Now that 1 really represents 10. So I add that extra 0 there because I'm multiplying everything by 10. 1 times 3 is 3. So that would be that 30 there. Then 2 times 1 is 2. Add your ones place, you get 2. 9 plus 3 is 12 tens. Regroup. 10 tens make 100. And then 1 plus 2 is 3 for 322. Our next algorithm is the lattice algorithm. We looked at a lattice algorithm for addition, so this is a little similar. We multiply our single digit values by place value, and then we're going to add the sums along the diagonals. So let's see how this works. Write 23 across the top and 14 down the right side. Notice that I've made columns under the 2 and the 3, and I've made rows with the 1 and the 4. I draw a diagonal from the top right to the bottom left of every box. Then I multiply. 3 times 1 is 3, or 0, 3. 3 times 4 is 12. And notice I put the 1 in the top triangle and the 2 in the bottom triangle in that box. 2 times 1 is 0, 2. The 0 goes in the top triangle, the 2 goes in the bottom triangle. And 2 times 4 is 8. So I have 0 in the top triangle and 8, the ones place, in the bottom triangle. Then I add along the diagonals. Well, my first diagonal is the 2. The next diagonal has 8, 1, and 3. 8 plus 1 plus 3 is 12, but I need to regroup, so I have an extra 1 in the next group. 2 plus 1 is 3, and then the last diagonal would be 0, and so we have 322. Let's look at another example. 543 goes across the top, and the 24 goes down the right side. Notice I have a column under the hundreds place, the 5, a column under the tens place, the 4, and a column for the ones place. I have a row with the 2 and a row with the 4. We draw a diagonal from the top right to the bottom left of every box. And then we multiply. 3 times 2 is 6, or 0, 6. The 0 goes in the top triangle, the 6 goes in the bottom. 3 times 4 is 12. The tens place, the 1 goes in the top triangle, and the 2, the ones place, goes in the bottom triangle. 4 times 2 is 8, or 0, 8. 4 times 4 is 16. Notice again the tens place, the 1 goes in the top triangle, and the 6, the ones place, goes in the bottom triangle. 5 times 2 is 10, and 5 times 4 is 20. Then we add along our diagonal. So we have 2 for the first diagonal. 6 plus 1 plus 6 is 13. I have to regroup and add an extra 1 to the next column. 1 plus 8 plus 1 is 10. Again, I have to regroup. 1 plus 2, and then my last diagonal is 1. So we have 13,032. Our fifth algorithm is we look at what happens when we multiply by 10 to some power. And you'll notice here that we add in zeros. So n is our power, and we add in zeros to the right of the original number. Well, here's kind of why this works, and then we'll look at how it works. Let's say I want to multiply 23 times 10, and I'm going to use base 10 blocks to do so. So 23 is 2 longs and 3 units. Now I'm multiplying by 10, so that would mean I would write this 10 times. I'm going to shortcut. I know that 2 times 10 is 20, so that means I have 20 longs. And 3 times 10 is 30, so I have 30 units. 10 units make a long. Over the course of 30 units, that's going to give me 3 extra longs, so I have 23 longs, and I have no units left. 10 longs equal a flat. Well, I've got 2 sets of 10 longs, so that means I have 2 flats. I have 3 longs left and no units. And so my answer here would be 200 from the flats, 30 from the longs, and no units. When I multiply 213 times 1,000, I have 3 zeros in 1,000. So I'm going to add 3 zeros to the end of 213, and that gives me 213,000. In part B, 56 times 100. 100 has 2 zeros. So I add 2 zeros to the end of 56, and that gives us 5,600. So again, we're writing zeros to the right of our number. How many ever zeros you have is the number of zeros that you write. So let's look at mentally multiplying numbers. First, we have our front end multiplying. So we multiply the tens place by the second number, and then the ones place by the second number, and we add the two products. Now notice when we do this, we will only have a 2-digit by a 1-digit number. So for 64 times 5, first I multiply 60 times 5, which is 300. And then I multiply 4 times 5 is 20, and we get 320. Now these steps would be done in your head. However, on a show work question on a quiz, you will have to show these two steps. Let's look at part B. We multiply 80 times 7, that's 560. 8 times 7 is 56. I've got the zero, so I add the extra zero at the end. Then I have 5 times 7 is 35. And when I add these two together, that gives me 595. Our next trick for mentally multiplying is using compatible numbers. So numbers whose products are easy to calculate mentally. In part A, we have 2 times 9 times 5 times 20 times 5. Well, I know that 2 times 5 is 10, and 20 times 5 is 100. So now I have 9 times 10 times 100. Well, 10 times 100 is 1,000. Then 9 times 1,000 is 9,000. Again, these steps should be done mentally, but on a show work question on your quiz, you'll need to write each step out. On part B, we have 5 times 10 times 2 times 60. Well, 5 times 2 is 10. I have 10 that I still need to multiply and times 60. 10 times 10 is 100. And when I multiply times 60, I'm going to look at the first digits. 1 times 6 is 6, and there are 3 zeros, so that gives me 6,000. Another way to multiply mentally is to think about money. So we think of our product in terms of pennies, nickels, dimes, quarters, and half dollars. So let's look at how this works. So 64 times 5, well, that would be 64 nickels. A nickel is worth half of a dime. So it's going to take half as many dimes. So we have 32 dimes. Well, a dime is worth 10 cents, so this would be 320 cents. And so 64 times 5 is 320. Let's look at part B. So we have 64 times 50. Well, the 50 reminds me of half dollars. So I have 60 half dollars. Well, since a half dollar is worth half as much as a dollar, I need half as many dollars. So that would be $32. Well, a dollar is 100 cents, so that's 3,200 cents. So 64 times 50 is 3,200. Let's look at one more. Here I have 64 times 25, so that would be 64 quarters. A quarter is worth half as much as a half dollar, so I need half as many half dollars. So I have 32 half dollars. Well, again, a half dollar is worth half a dollar, so I need half as many dollars. And a dollar is worth 100 cents, so that would be 1,600 cents. In other words, 64 times 25 is 1,600. Now let's look at estimation. Now we're going to start with front-end estimation. Now this is different from the front-end multiplying that we talked about with mental multiplication. Here we are estimating and not finding an exact answer. So 524 times 8. Well, 500 times 8. Looking at that first digit, 5 times 8 is 40. And notice I've got 2 zeros, so I need 2 more zeros there. Then I'm going to look at the next digit is the 20s. 20 times 8 is 160. When I add these together, I get 4,160. Again, this is an estimate. In part B, I have 600 times 5. Well, 6 times 5 is 30, and add your extra zeros from the 600. Then I have 80 times 5, that's 400, and add these together is 3,400. Again, this is an estimate. Our last strategy for estimating is looking at compatible numbers. So again, these are numbers that are easy to multiply. Once again, don't confuse this with the mental computations. Mental computations are going to be exact numbers. These are going to be estimations. Our directions here ask us to use compatible numbers to estimate. Well, 500 times 8 is easy. That's 4,000. Now, 8 times 24, I don't really know what it is, but I do know what 25 times 8 is. It's 200. Add these two products, it gives us 4,200. That's my estimate. In part B, we have 600 times 5, which is 3,000. My next digits are 8 and a 1, so we have 81. Well, that rounds to 100, and 100 times 5 is easy to multiply. That's 500. And 3,000 plus 500 is 3,500.